both they work for IDOM, and I'll have to explain a little bit at first sight. So they are the architect studio within IDOM. So IDOM is it's difficult to make accurate comparisons, but it's a kind of consulting engineering group, very large. It's based originally from Spain, and is based pretty much all over the world. Their architecture department, to put it another way, is about 70-odd architects strong, right? And they are like a studio, any other architect studio around the world. They are that kind of size, 70-odd architects or so. And they have commissions like any other architecture studio. But what I find very interesting is that they share with the whole of the group, IDOM, a kind of special culture, which is that basically when you come to them, their attitude is everything that you ask, everything that you want to do, we join there with you, and we'll stretch whatever it is, technology, management, anything, to make sure that we together make that a reality. I think the Guggenheim Museum is a good example of that. Some of you, I can see some faces here, have heard me many times in the first term, that there's no such thing as a design and construction, that there's one thing. Basically, to build is just to materialize a concept, an idea. Well, what they're going to do tonight is just take us through what happened there. The task was absolutely mammoth. If you know the work of Frank Gehry, to materialize an idea, a concept, and when you see the first sketches, you realize what the task that they actually joined in to achieve. So that's the task that they took on, and they had to go to the States, get to know the project, contribute in the development of that project, and then build it. And build it for Guggenheim Museum, which again is a culture where you don't do things in halves. You do it well. And so what we're going to do is that Cesar is going to start first to put more or less the project in this context, and then Fernando will continue, and then they're happy to answer questions on the end of the lecture.
Good evening, everybody. Thank you very much for this invitation to the AA. I don't speak English, I will speak in Spanish, and Fernando will translate.
He says he doesn't speak English, but he does.
El Museo Guggenheim de Bilbao surge como una confluencia de intereses entre las instituciones del País Vasco y la Fundación Guggenheim de Nueva York.
Okay, so to understand the Guggenheim Museum, we have to think about two different factors, two different issues. One of them is the Guggenheim Museum in New York, and the other is the Basque government in the Basque country, in Spain.
La Fundación Guggenheim de Nueva York, desde sus orígenes, tenía planteado expandirse en todo el mundo con museo con arte moderno y contemporáneo. Y por otro lado, las instituciones del País Vasco, en la década de los 80, se habían replanteado surgir de una profunda crisis económica y social, siendo como motor de ese cambio el arte.
So on one side we have the Guggenheim Foundation looking for expansion all over the world. That was their philosophy. And on the other hand, the Basque government wanted somehow to get out of a very difficult crisis process that, well, now we will show you some pictures. But there are these two factors together that have as a result, one of the results of those two things together are the Guggenheim Museum.
De esta manera se buscó un arquitecto que hiciera un edificio emblemático para poner a Bilbao en el mapa mundi.
So the purpose of the Guggenheim first is the first idea was to create a landmark so that Bilbao would be now in the world map. That's one important idea.
El equipo que se formó estaba constituido por 4 partes. Las instituciones del País Vasco, que crearon una sociedad privada, la Fundación Guggenheim de Nueva York, el equipo de Frank Gehry como diseño e IDOM, nosotros, como arquitecto ejecutivo.
So there were 4 parts involved in the process. One is the Basque government, who created a kind of company, let's say. That's Guggenheim Bilbao. Then it's Guggenheim New York. Then it's Frank Gehry as a design architect, and then IDOM as an executive architect.
Las instituciones del País Vasco son las que han aportado todo el dinero para hacer el edificio, que es propiedad del País Vasco.
So all the money for Guggenheim was given by the Basque government. So they own the building.
La Fundación Guggenheim aportaba su conocimiento museográfico definiendo el programa de necesidades hasta sus más pequeños detalles.
So the Guggenheim Foundation, they gave, let's say, the knowledge of the art world, and also they defined the program of the building, even to the smallest details, like, I don't know, lighting, air conditioning, that kind of things.
Frank Gehry, en el año 92, que comenzó este proyecto, tenía un estudio de unos 80 arquitectos, de los cuales dedicó a 40 arquitectos durante 5 años al desarrollo del proyecto, que era el más grande que había tenido.
So Frank Gehry's office at that moment was about 80 people. 40 more or less were involved in the museum during 5 years.
Nosotros, IDOM, tuvimos una dedicación de unas 50 personas durante esos 5 años, llegando a tener en momentos punta hasta 150 personas de dedicación al proyecto.
So IDOM, our company, we worked around 50 people during 5 years, and in some peaks we had even 150 people working in the project.
El proyecto era multinacional, ya que la Fundación Guggenheim estaba en Nueva York, Frank Gehry estaba en Los Ángeles y nosotros estábamos en Bilbao, con lo cual manteníamos reuniones cada 5 semanas, una semana, las 4 partes del equipo, para ponernos de acuerdo en toda la programación del edificio.
So communication was a crucial factor, because you have to think that, well, there were people in Los Angeles, there were people in New York, people also in Chicago, then in Bilbao. So it was crucial to have these meetings and constant communication among all the parts involved.
Quien gobernaba el proyecto desde un principio fue las instituciones del País Vasco, que eran las propietarias del edificio y eran las que marcaban los objetivos fundamentales en cada una de esas reuniones.
So all the process was, the leader was always the Basque government part, in the Guggenheim Bilbao. No? That was the leader, and all the goals for all the meetings were established by this part.
El proyecto, como explicará Fernando ahora, se caracteriza por tener una enorme complejidad geométrica que se ha traducido en una enorme complejidad constructiva, teniendo sistemas novedosos y materiales novedosos.
We will talk now about all the process of construction, and you will see the complexity of all the systems, and also the complexity of the geometry. We will see now. Okay, so it's my turn. Okay, so Bilbao, that's a satellite image of Bilbao. You see a linear city that, as we were saying, there was a very, very important process of crisis in the late 80s. I've brought some pictures. Some of them have already disappeared. This is not possible anymore. This landscape of chimneys, the steel furnaces, and all that. This was a huge company, a steel factory, one of the biggest. It was called Altos Hornos de Vizcaya. Shipyards, all of them, all along the river. No? Bilbao is a linear city, more or less 1 million people live there. This is again the same. Today this has disappeared, and there is a much modern electrical steel factory here. And this is one image that somehow represents this process of change. This was during one weekend, these huge, massive blocks, concrete blocks, they didn't want to fall down. And it's a kind of metaphor of this process of change. So Bilbao, that was a very important industrial city, one of the most important in Spain, with this process of crisis was losing people, and there was a huge problem of unemployment. So the authorities realized that they had to do something. And this is, I mean, the museum is just one part, one piece of a huge process of change, including huge investments in transport, communications. I don't know, I'm sure you know about the metro designed by Norman Foster, or the brand new airport by Santiago Calatrava. The exterior port was very important because all the port of Bilbao was all along the river. For instance, all this area that is called Abando Ibarra, where you see the museum up there. Let's see. And this is an opera house. And all this was part of the port of Bilbao. So the enlargement of the outside port by the sea gave the chance to get back all this land for the city. As you see here, had a very clear limit. So another part of that process was culture. I mean, Bilbao had never been a cultural city or a tourism city. And some of the people of the Basque government, it's interesting that they were part of the economic part of the Basque government, thought about a building to transform the city. Somehow it was a dream. And what we are going to tell you today is how this dream was built. Javier was talking about an idea. I would say it was a dream. Somebody said, well, why not a building? Why not a museum to change the face of the city? That was the whole purpose of the Guggenheim. And that was the place. And as Cesar was saying before, on the other part of the ocean, there was the Guggenheim Foundation, looking for cities in Europe to open a new, let's say, branch of the Guggenheim Museum. And there were several cities involved in this process. I don't know, maybe you remember some projects of Hans Holle in Salzburg, for instance. Well, and that was the place. You see here the very clear limits of the city. And this flat land, 8 meters more or less, below the general city, and the river Nervion, that's the name. At that time, Frank Gehry was already working. Well, we could speak also about why Bilbao. Maybe later with the questions, maybe we can talk about all these things. We will focus on architectural process. But at that time, Frank Gehry was already working for the Guggenheim Foundation, and he helped the authorities to select the place, because in principle, Basque authorities wanted the building to be built within the city, in an old winery building inside the city. And Frank Gehry said, well, if you want to recover the river, why not build it in the river? No? So that was one first idea of Frank Gehry. Well, history says that he was upside in the hills. No? Bilbao is surrounded by hills, and he saw this place in the bend of the river with the bridge, this huge bridge. It's almost a highway going inside the city. And he selected this place. There used to be a factory there with an old brick chimney. So he selected the place. And there was a very, very small competition with 3 groups of architects. This was Arata Isozaki proposal. This was Kop Himmelblau. You see here the brick chimney and part of the existing facilities. Well, and this was Frank Gehry's sketches. So I like to speak about the history of the museum as a history of miracles, one after another. Maybe for me the most important is the first one, I mean the political moment. That's the first decision, that's the most important. Second, maybe, is having chosen Frank Gehry instead of the others. No? Especially if you consider that Bilbao, from a cultural point of view and even architectural, is a very classical society. But somebody thought that with this architecture would be the best for this goal. I mean, putting Bilbao in the map. So these were the very first sketches. It's very interesting to follow this process from the very beginning, where you see here the river, the bridge, and you begin to see in these very first sketches all the pieces that will survive till the end. No? With this big piece, the atrium, a kind of big plaza, with the main entry here, with the plaza here, and some blocks with these three main pieces. This will be the fish in the end, and the others, the classical galleries. And with this, the city going down, getting to the plaza and facing finally the river across this water garden. So these were first models of the process where you can find almost everything, every of the little pieces that will be in the end. So it's as usual, Frank Gehry works exploding the program that was established by the Guggenheim Foundation. So they decided the number of galleries and the area of every of them. And well, Frank Gehry explodes this program. He usually does it, and then begins to play with these little pieces. Well, this is Frank Gehry's office in Santa Monica in California. At that time, I was a student. I was at that part of the table, and I had an opportunity to go there, thanks to a grant of the Basque government, to go there to the Frank Gehry's office in Santa Monica, and I spent a couple of months there working at Frank Gehry's office. It was interesting because at that time, well, Frank Gehry was not less known, let's say, although, well, it was very well known, of course, among students, but at least in our school he was considered almost the devil. And, well, I filled in the form just joking, and they selected me, and I said, oh my God, what am I going to do there? So that was my first view of the factory. And maybe this is the second. No? I crossed the door and I discovered what was called the Bilbao space. And I discovered this world of thousands of models, pictures. And I think this is the best thing to understand. I mean, thanks to this experience, I had the opportunity to understand the way that how Frank Gehry works. It was very important for me to follow the whole process of construction. I had somehow the idea, it was a mistake, but that Frank Gehry's architecture was kind of frivolous, something like that. I forgot immediately when I saw this huge process of work, and I understood that all these pieces, all these shapes are the result of thousands and thousands and thousands of models, one after another, with minimum difference between one model and the next, with a huge amount of work. This is Chris working in the fish. As you can imagine, making a model of this is not easy. Well, I've seen your big shop of models, and I know you are used to do this, but it was incredible. When I arrived there, this was more or less the building, so it was almost finished, the design. You see here they use, micro cameras to go through through the building. And everything is studied in the models. I remember the sentence was always, when you had a problem, I remember I was working, drawing sections. And whenever I had a problem, the answer to my question was always, let's look at the model, because the answer to the question was always in the model. Obviously, it's not an architecture made of plans, of drawings, of elevations. Always the model. You see here, this is important, there are these kind of parallel lines. For me, I had the impression that it was a never-ending process. When I saw them working in the models, when I was also part of the team, I had the impression that if we had 5 years more, we could go on 5 years more developing the building. But here there was a very important part of the process, that is the client, who wanted the building to be built, to be open in the summer of '97. So somehow this process had to stop. And they call it to freeze the design. And you see here these lines. That's the way they transform the information of the model into the computer. I mean, they read with kind of pencil all these lines, and they transform it into the computer. Well, part of the people, including Edwin Chan, who was the designer of the building. He has the strange ability of understand Frank Gehry's ideas and share them with the rest of the team. You see there are, models of all the urban area, including a model of a pay building that was never built. Okay, aerial view. You see all the models, general, then all the galleries, everything is decided with models. Well, you see here the final layout of the building with the central atrium under this big piece of metal, the flower. So you hear the organization is more or less the same with these three main axes. It's the classical gallery east, the fish is the temporary gallery, temporary exhibition under the bridge, and then the classical west. And then among them all these pieces, all of them with their nicknames, with Captain Nemo here, or Zorro here, T-1000 and the fish, the canopy, the boot, the river gallery, and above all of them the flower. So this is the atrium with the whole height of the building, and everything is organized around this space. I'm sure a lot of you have been there in Bilbao, so you know how it works. Models of the atrium that in the beginning was a much wider space, and then finally ended in a very vertical, very narrow space, searching for the light coming up from the flower. Okay, so this is an image of CATIA. CATIA is the software that Frank Gehry discovered. They used it for the first time in the fish of Barcelona. And it was a very important tool for Frank Gehry because it allowed him to build the shapes and the forms he was creating. Until now, he had a lot of problems because he had to make thousands of drawings to transform the information of the models to the contractors. So nobody wanted to do that. I mean, every contractor was facing a huge pile of drawings, and the buildings were very expensive. Nobody wanted to build them. So it was very important for them to find a tool that in the end was the tool that was going to make possible this architecture to be built. So this was CATIA that was developed in the beginning as aerospace software. And it's very interesting because they are not only using this software, but they are somehow creating it, because they are working with CATIA technicians in order to develop the software in the way they need it and the way they want. So finally, Frank Gehry found this tool, and all the museum was done with this software. So what did we receive from Frank Gehry? First, a lot of information, I mean, in terms of drawings, sections, typical details. But then it was crucial, this information in CATIA, I mean, all the shapes of the building. I have to say, however, and this is very important, that from the very first moment, we were working together as a team. I mean, it's not true that Frank Gehry was working in the beginning, then he finishes, and then we begin to work. But we were working together from the very first moment. And I think this is really nice as an experience. Maybe for me is the best. I mean, this human part of the experience. How these two different cultures, in terms of everything, I don't know, also construction and architecture, these two different cultures meet and have this long way of 4.5 years, 5 years working together. All of them following or working to make this dream possible. So at that time, for instance, we were working very hard trying to know what was the budget for this building, because we had from our client a very, very clear budget and a very clear goal. So we were working with a lot of different contractors trying to know how much does it cost. But it was not easy, as you can imagine, because all the construction systems of the building were not usual at all in Spain. Well, some plans of the building where you can see the big gallery. In yellow you see the galleries. In blue there are public spaces, and in pink back of the house, mechanical. So maybe here you see the structure of the building with the river up there, the plaza here. And it's very interesting how the building saves this 8 meters difference between this point and that point. How you go down through this ramp, how the scale of the building towards the city is quite quiet, and then how it goes, you know, thanks to this difference of level, it goes down, and then the building gets higher and higher, and you know, gets to the maximum in the face of the river. Okay, third floor. There are only well, there are 3 floors for visitors. And well, this is not Roman. It was Bilbao at the time, no? This was October '93, exactly 4 years before opening. And we began to work in the foundations of the building. There were 600 piles. As you can imagine, it was not easy because the river was very close. And well, the construction of the structure began. The structure was developed by SOM in Chicago. And Frank Gehry hired SOM to do the structure. It was very interesting, the process of design of the structure and concept. I don't know what happens. This one. I don't know if maybe because SOM was facing a very difficult problem. For them, the most important thing was that there was no reference before of how to make a structure for a building like this. Of course, they had very clear that they had to find an economic system to do it, but always keeping the architectural solutions as they had been designed by Frank Gehry. So they created this this kind of web, a structural web. It's not a structure made of columns and beams. You see that everything works together. It was very important to establish first the module, where there was a very first idea that was very first decision was to use concrete or steel, because Frank had made some previous buildings with concrete and they had been successful. So SOM, on the other hand, wanted to build it in steel, and they had to convince Frank Gehry's people to do it in steel. Okay. All the structure was done by a contractor very close to Bilbao. Of course, the client, the Basque government, wanted the building to be built by local contractors as much as possible. And this was done by Ursa, very close to Bilbao. And well, Frank Gehry's people accepted in the end that they had been a fantastic process. They had never seen something similar, even in the United States. This how to transform this information from the CATIA to something built. Ursa used this software called Bocad. It was a German software that allowed them to, draw every single piece of the structure. This was very important to check and coordinate with architecture, and to check that there were no interruption between the internal structure, the main structure, and the exterior and interior skins of the building. It was also very important to decide how this structure was made. It was important that there was they knew that the most economic structure would not be the most, let's say, the one that was calculated to the minimum sizes of the members, but the most rational in terms of fabrication and installation. So it was very important to decide the typical module, then the joint, then all the members are linear, there are no curved members in the structure, but it was very, very close to the final surface. It's also nice to see how this structure works as a web and works together. I mean, until you have not put the final beam up the very top, it doesn't work. So this is why we had to tie all these big structures to the classical galleries that were the most rigid elements of all the structure. It was nice, of course, as you can imagine, to follow the whole process of construction and climb up there every day and see all these pieces growing. No? This is, for instance, Captain Nemo. And it was nice to discover the space, because somehow all the interior spaces of the building were already done at this time. This is the atrium. I was pretty scared about, I don't know, what Bilbao is going to say now. But it was interesting because nobody seemed to be too angry when seeing this building. Of course, there were voices against the museum. Somebody saying, well, why wasting so much money in a building like this? Why not making small cultural centers all around Bilbao? This is structure in the end with all the fireproof on it. And then this is the second phase. We decided to divide the construction into different parts using different contractors in order to make the process shorter. It was a fast-track system. Design was not finished when foundations and structure began. So this had some risks and a lot of work of coordination that was in our hands because we had to work with different contractors. So the main structure was done by one contractor and the secondary structures for the skin was done by another. Also in our team we were divided also in the same parts. Cesar was at the very top coordinating all of them, and well, I was in charge of the next chapter that was exterior works. So here you see the main structure and a series of secondary structures that allow to pass from this polygonal surface to the final curved surface. Here you see these elements we call the secondary structure, everything made of galvanized steel. All of them, all these elements built in a shop and installed on site with a very precise topographical system. Then on top of these structures we put this galvanized continuous sheet. That's the thickest element of the facade. It's just 2 millimeters thick. And this is, well, how we began to have first reflections, not titanium jet. At that time, we hadn't decided about titanium jet. We will talk about it later. But we have already these really nice views of the museum, very different from the final images, with this very tense skin. This was 1 year before the opening. And well, as you can imagine, we were rushing very hard to get to the final moment because we had in the end 3 main goals. First was to finish the museum with the expected level of quality. Second was to finish on time, and third on budget. So there were 3 different goals. As you can imagine, not easy. During all this time, it was fantastic, We didn't have time to get bored. Every day, our day began always with what we call reading the newspaper. The newspaper was a lot of faxes coming from Santa Monica that were the answers to our previous questions of the day before. It was interesting that we were a 24-hour working team because they were sleeping while we were working. So it was that was very convenient for our work. And also, we had very clear ideas of our roles. I mean, we knew that everything that had to do with design or aesthetics had to have the approval of Frank Gehry's office. And on the contrary, they knew that we were, in the end, responsible for the building. I mean, we are signing for the building, so we have to accept and approve all the technical solutions. And this was very interesting because the way they usually do things and they work are usually very different from ours. So these were some nice views already disappeared. This is the Boot Gallery and the River Gallery. Towards the interior, we have this would be the main structure with the fireproof. This is the secondary structure. The galvanized metal is underneath this layer of thermal insulation. In the exterior, this is a very important element, that is the waterproofing. We studied a lot of different solutions to do this. We made a lot of tests. We worked with several contractors. We worked with one university in Spain, checking different systems for the waterproofing. And we ended with this membrane. As you can see, we put it on top of the galvanized. And it has a very important property that when you screw through it, the hole is closed. It's a self-healing membrane. as you can imagine, also going up there every day was amazing. I was lucky because I love hiking and climbing and do these kind of things. And it was also, you know, this is already lost. I mean, nobody has the opportunity now to go up there and discover these marvelous views of the building and the city. With, you see the structure of the tower. I haven't talked about the tower. It's a very important element on the other side of the bridge. You see the bridge there. So somehow the tower traps the bridge into the composition of the building. Okay, so titanium. Why titanium and not other things? I remember we began with you know, these things down there. You see the number 1 was alloy of lead copper. Frank Gehry wanted always to avoid a very shiny building. He had done, I'm sure you know about previous buildings made in stainless steel, you know, these very flashing buildings. Here, the building was much bigger, and he wanted to avoid this effect. And also, he was very worried and concerned about how the building would like in Bilbao. He knew that Bilbao was a rainy city, you know, with you know, very cloudy weather, usually raining. In fact, he was very upset because every time he came, it was shiny. And he said, "Well, this is not the thing you told me." No? And he was trying to get the perfect material for that light. And it's incredible. I mean, it's only an example, but I think it's a good example to show how they work. Never ending in a solution that we already know. Okay, we have done previous buildings in stainless steel. We know how it looks like. Let's go one step ahead. Always. That's the rule every time in their head. So they wanted to discover something different. And as you can see, we brought a lot of different samples. We ended finally with this colored and scratched stainless steel. But one day, I remember they came with a sheet of titanium, and they put it here in this kind of mock-up. And well, there began a huge process of development of a new material. Because, of course, if you go to the manufacturer of titanium and ask for a sheet of titanium, you don't get the final result. And it was very interesting how they worked together with the contractor in US and ended with the final material. And it was really nice to work there with them. I remember spending hours with a pencil up there in a ladder, and Frank Gehry was 20 meters away, and I was putting the pencil closer and farther so that he was checking how was the reflection of the pencil in the different types of titanium. So this was incredible. So this is how we changed from this very tense skin to this kind of pillow effect. That was something that they wanted. They wanted to avoid this huge scale, so they decided to make these smaller pieces, so that you can get easier the scale of the building. And also they wanted these bumps, so they decided to use these very, very thin titanium sheets. They are just 1/3 of a millimeter, so they are almost like a sheet of paper. So they create this kind of bumps. They are fixed to the galvanized that is underneath the waterproofing by means of these cleats. As you can see, there are 2 screws per cleat, 8 cleats per titanium sheet. So you have thousands and thousands of screws through the waterproofing membrane. As you can understand, this was a very risky solution. But we made a lot of tests and we ended that it was a good solution. So far it works, and it works very good. We haven't had any problem with the metal surface. And then it's very nice, this property of titanium of catching the different lights and catching reflections. It changes a lot depending on the weather, and if it's sunny or it's cloudy. And it's a building that, well, you discover new views every day. I mean, we spent there 5 years, and every day was different. This is one view from the tower. It's impossible to go up there. This is the best place of the building for me. So, really nice terrace. Nobody there, just titanium and sky. It's incredible. Here, for instance, you see this golden color. It's a reflection of a stone surface that is maybe 50 meters away. You see here this pillow. It's not true that all the panels are different. There are families of panels. It was very interesting also from a geometric point of view, all the pattern of all these lines going up and down. And then, of course, all these panels in the edges had to be done on site. This was done also by a local company called Umaran in association with an Italian company, Permastelisa, that had worked with Frank Gehry before. So views from the flower. He loves to use metal also because this material allows him to wrap all the surface with the same material. Here you can see the relationship between the building and the bridge with the tower and these T-1000 mouths eating the bridge. T-1000 was the bad guy in the Terminator film. So this is when I began to discover why so many thousands of models. And you begin to see these lines of the building almost finished. Like this is the T-1000. I don't know, after a lot of visits to the museum with a lot of people, now some of them ask why. I don't think this is an architecture that you can ask why. And this is also an important part of the process. I think he works with a lot of freedom, also because within his team there are people dedicated to design and also people dedicated to solve the problems. But when they face a problem, they never get back and say, well, let's look for an easier way. They always push until they get the final answer. And it was nice how this philosophy of work was, in the end, our philosophy of the whole team. So we never said to Frank Gehry, no, this is too difficult. Well, a general view with all the metal shapes and the skylight, the C-22 at the very top. It's also important, the budget control. It was very difficult, but it was nice how Frank Gehry got involved into this game of controlling the budget. He wanted the building to be done. He had some previous bad experiences with buildings that were not built due to budget problems. So when we were monitoring the cost and we said, well, this is, let's say, 50 million pesetas over the budget, he said, okay, let's do something. He never said, no, this is my building, don't touch it. He said, okay, let's look for ways to reduce the budget, to cut the budget. I remember this because C-22 was in jeopardy one time, and we took it from the model. In the end, they said, no, this is an important piece, and there it is. I think it's important. It's kind of eye on the very top of the building. Here it is. And you see how it changes, depending on the light, the color. Well, just some pictures of the tests we made. It was in a laboratory in Italy that we made this mock-up to check it, to check the waterproof. This fan throwing wind and water against the mock-up. Well, this is a problem that I'm sure you have noticed if you have gone there. This kind of different colors between one panel and the other. This is somehow the result of this process of trying always to go farther. If we had done it in stainless steel, it would have been uniform, perfect. And here I remember we began with this panel. This was the very first, no problem. And then we get to this one, and there was a huge crisis. Also, the history of the museum could be done through the different crises, with problems, huge problems at the time, and that was one of the most important. And this was, part of the game. It was a very, very delicate process of fabrication for all these panels that they go through acid baths, and it's a very delicate process. In the end, very, very difficult to control because it depends on temperature, on a lot of different issues. So we had this problem, and we didn't know how to solve it. So we had to add another step in the process of titanium fabrication and installation. That was to measure the color of every single panel in order to sort them and to build some facades, let's say, with darker panels and other with lighter panels. Because this effect, you can appreciate it when they are together. Okay, faster I will talk a little bit about stone. The general rule was these huge, massive pieces of stone, kind of metaphor of the city going down towards the river. And then on top of them, these huge metal shapes. This is sorrow. So in general, the rule was these flat surfaces made of stone and curved surfaces made of titanium. It was very interesting also the research we had to do looking for a stone. He wanted a stone to be similar to the typical sandstone in the Basque Country, but it was too soft. So the problem was to look for a harder stone, but with this yellowish color. We looked for a lot of different stones all around the world, and we ended finally with this that is from a quarry in the south of Spain, in the province of Granada. This is, for instance, this piece here is a mock-up that we did for the glass areas. We will talk later. Here, well, the technology was not so difficult. I mean, it was there were concrete block walls with polyurethane sprayed on insulation, and then the stones fixed by means of stainless steel cleats. This was easier, although, well, we established a very, very strong process during construction because Frank Gehry wanted to avoid a checkerboard effect. So we had to refuse a lot of stones and establish a process of saying this yes, this no, this yes, this no. It was quite hard. Well, this general rule I was talking about is sometimes broken, like here, where you have these curved surfaces. These are, let's say, still easy. They are cylinders, although, well, these points were quite problematic. But this rule is finally broken in the tower at the other side of the bridge. This was the element that they designed, the final one, maybe the craziest, with this very, very delicate and thin skin of a stone that you can see it here. It's just 3 centimeters cladding, leaving the structure exposed. It's the only place in the museum where the structure is exposed. Engineers blame on us architects for covering that marvelous structure. There were many, many different versions of the tower, including some of them with a restaurant at the very top. We couldn't do it in the end for budget and also security reasons, because we had to add, the elevator, 2 different stairs, fire code and all that. So this was during construction. It was also the final element to be built just some days before the opening. And it was nice, you know, to go up there every day. Huge. And here, it's, let's say, always searching for limits. These were the limits for construction with a stone, with this very delicate cladding, but well, we had to do, for instance, a single CATIA file for any of the stones because the curvature is different. Not only the curvature of this face, but also the angles of the four little faces around. And well, this is more or less the final result. I think it's the second one. Of course, if you have any question, just do it right now. I think it's good. Now we are going to talk about the. Let's see if it works. Okay. So the third element in the exterior is glass. It was a requirement of the Guggenheim Foundation that galleries shouldn't have windows because, you know, a beam of light directly on top of Kandinsky, it's a crime. So light inside the galleries has to be very, very controlled. So they wanted these dark spaces. In the end, we had only one, you know, some skylights at the very top that have some mechanisms to control the light. So light appears when you go from one gallery to the other. I mean, natural light. And it's also the element that allows, you know, these pieces to be independent from one another. No? This is Zorro and this is T1000. In between this curtain wall. So they are kind of joints between the elements. No? Here you have wood and river gallery, and there you have that glass piece. And this is the main one, the one facing the river, C10. And you see there, there are two different parts. This part here is quite easy. Well, it's made of this rectangular module. But up there you see that this rectangular module is divided by a diagonal, so we have two triangles. And this allows the general surface to, you know, to twist. And always working with flat pieces of glass, we can get to these curvatures. Glass was by far the most difficult part in terms of engineer, design, construction, even leaking. We spent a lot of months before the opening checking with a pressure hose, checking that there were no leaks through the curtain walls. Here you see this, what we call the faceted areas, with the final caps on top. This was the way the corners were solved, always by means of this free glass at the edge. But it was also a problem because you know, we were using glass pieces with air chamber, and of course we didn't want this very thick thing appearing at the edge of the glass piece. So we had to develop this special kind of glass with the two leaves of the glass are of different length. But then again, this was you know, a lot of people working and thinking around the world on how to solve this problem, and never the answer was no, this is too difficult. The answer was always okay, let's try. And it was interesting how we found a lot of contractors involved in the construction of the building. I mean, and they knew that they were making something very important. And working there, you had the feeling that, well, we all are working together to make this building possible. And somehow we all knew that we were making or building a dream. Some very difficult pieces of glass almost 50% of the pieces were done several times because you know, they were broken or they didn't fit, or you know, it was difficult. Or you know, crazy places like this that I never understood. It was one of the mouths of T1000. It had a double layer of curtain wall because you know, it was facing directly the bridge with a lot of traffic, a lot of noise. So also the acoustical requirements were very important. And well, I show some, you know, dirty images, I would say, you know, because these were our daily problems up there. Of course, we had a lot of typical details of showing how to solve the problems, but of course we had particular situations everywhere. And every day we went up there, oh, there is a problem here, okay, let's go there and let's look for a solution. No? That was our life during these 4 years. These are some flashings and waterproofing at the very top in the C22 in the skylight up there. But, well, this is the result. The contractors complain and say, well, it looks easy. And it's somehow true. I mean, the difficult thing is underneath. And this is, I think this is why it's interesting, this lecture. I mean, how to show you the process and to understand that a building is not just the final thing already built, but all this process is very important. Reflections, titanium glass. And interiors. I don't have too many slides of interiors because it's interesting because it's building difficult to, you know, to take pictures of it from inside because, you know, it's difficult to trap these spaces within a picture. And again, here it was fantastic to follow the whole process of construction. Also because I found it more consistent with the way they work, with this process of never-ending transformation. It was interesting, for instance, that you know, they were every day changing things before construction. And you know, everybody was a bit upset with this, you know, with receiving this huge package of drawings different every week after another. In the end, they decided to eliminate the word change from their vocabulary. And they say, well, let's talk about improvements. So there were no changes, there were improvements. And it was nice to see the building improving every day with these fantastic conditions of light, noise. You know, it was a kind of factory. Now, if you see this space, you know, it's white, perfect. It was really nice like this. You know, during all this process, we used to have a monthly meeting with Frank Gehry's people, with also the people from the Guggenheim Foundation involved, and of course the client, Guggenheim Bilbao. And these were incredible meetings of, you know, 10, 12 people solving all the little problems, little and big. Here you see, you know, the main structure, the thermal insulation, also, you know, some mechanicals, you know, air ducts, and a lot of things. Then the final layer interior of drywall. It's interesting to see how the building is, you know, very consistent when you see it from outside, and the interior is, you know, the space of the interior is, you know, it's a direct translation of the exterior of the building with this big skin with the main structure on the outer skin and the interior skin. Of course, drywall was also a crucial thing to make all the interiors. We made a kind of competition between different contractors to see how they wanted to do it. In the end, we chose this system based on this metal stud. We call it a snake. That allowed to get all the final curvature, but in the end, same as in the exterior, it was a very handmade building. I think it's the less industrialized building in the world. And I think it's not a good example to follow for any kind of building. Of course, you have to think that this is and it has proved to be a good system for a kind of a landmark like this building is. From all the moments that I remember from the construction time, this is maybe the most moving for me. Was the 12th of April 97, when all the scaffolding of the atrium was taken out, and it was incredible. 70 people worked during 1 weekend, throwing all the bars because they had to finish the atrium. The schedule was very, very tight. And it was nice because we had discovered these spaces first, as with this web of the structure. Then we closed them with the exterior skin. Then we put all this enormous scaffolding inside to make all the mechanical systems and all the drywall. And then it was nice to to begin to discover again this space with these final and smooth shapes inside. And the light, maybe it was the most important. Of course, another very important part of the building was all the mechanical systems, air conditioning, lighting, because there were very strong requirements from the Guggenheim Foundation and also from Frank Gehry's office, because they didn't want all the air diffusers, for instance, appearing here and there. So they took a lot of care, and they were involved in the design until the day of the opening, working with us in resolving all the technical details of the building, including lighting. So some interior. This is what is behind the drywall. It's incredible. I mean, it's fantastic to go up there, to go inside the ceilings and to discover this world. And here you understand how difficult it was to do it. From outside it looks more or less simple. Okay, so as you can imagine, after these 4 years and a half, 5 years of very hard work, suddenly the museum, the day before was, people shouting in the atrium, workers working very hard, and suddenly, the day after, it was like this. This kind of present, it was present to the city. The building, it was not ours anymore. We had lived there for 4 years and a half. Now it was a present for the citizens. And then that's, the beautiful part of the story, how the building has succeeded in transforming the city. How the dream of that very first person now is a reality, and now it works, and it really has helped to transform the city. Not only with thousands of visitors, but also they have put Bilbao in the map, really, and there are a lot of new investments. Hotel companies or industrial, a lot of new life around Bilbao. And it's nice to see, the power of architecture to do this. I think it's a very good thing for us architects that a building can help to transform the city like this building has done, what has been called the Bilbao effect. So these are some, final views of the museum already finished. I haven't talked about the urbanization around the building. The building is here. Always the building was surrounded by water gardens, always by water with the fish inside the water. Although I remember one day of crisis, we didn't have money for it, and Frank Gehry decided to delete the water gardens. Finally, we succeeded in putting them again There you see the reflection of the Deusto University right in front of the museum. I don't know, I'm sure you can, there are a lot of different points of view to analyze the building. Maybe we can talk now. We can exchange our ideas about the building. But it's nice to see also how, I don't know, sunsets are now incredible thanks to this piece of architecture. Well, these are just a couple of slides of. We are still working with Frank Gehry. This is a new building. It's a much smaller building, kind of a hotel by a winery in La Rioja in Spain, just an hour drive from Bilbao. I take it here to show that how this relationship between Frank Gehry and us didn't finish. I mean, it has finished. It's nice to see how these two different cultures that I was talking about has ended in a very close relationship of almost friendship in some cases. How, when he began, when a client proposed him to do another building in Spain, he said, okay, but let's do it, let's repeat the same team. And this is how we are working with this one, much smaller, but more crazy, even, much more difficult. You remember, always one step ahead, never staying in a quiet and comfortable position, always trying to look further. What's the limit? Who knows? And well, just some final views to remember all the process with the structure, the cladding with the galvanized and first titanium. You see also different lights, different conditions. Sunsets. The tower by night, it's also really nice, the building. No? Frank Gehry didn't want to light the building from outside, but just let the light from the interior go out. And it's nice to see it, in the dark. Glowing, with the lights of the city and the moon. And I think that's all, so I'm open to your questions. Thank you.
I think there are some microphones that you can actually have there, and then if you just make an indication with your hand, anybody who wants to ask questions. Fernando will be able to answer them as in strict rotation. So, now, are the microphones around? Right. If anybody wants to ask a question, just grab hold of a microphone and that's it. Okay?
Just a technical question regarding the setting out of the primary structure. Was that done with total stations, or I'm just thinking of the actual surveying of the alignment of the structure itself?
The structure was done from the beginning with a clear idea of prefabricating it in the shop. So everything was pre-done in the shop, then cut it into smaller pieces that could be driven to the place with a truck and then reinstalled on site. And of course the topographical systems there were crucial and they were very important. And everything worked very well. We had only one problem with one of the pieces where all the structure was kind of, twisted, just some degrees. And then it's interesting because the next contractor who came with the exterior skin, we couldn't twist the skin because it had, it was a nightmare to change all the files and all the computer information. So what we had to do is to adapt using larger in one side and smaller in one side secondary structures. As you have seen, the secondary structure allows for, has a tolerance with a telescopic element that allows to, reduce the tolerances of the main structure. But everything worked very well. I remember we had some problems with the first facade that we began to clad. We got to the first window and there was a diagonal bracing crossing, and that was the first one, and we said, oh my God, if this is the first one. Then we didn't have any single problem apart from that. There was a very minor intersection between one steel member and the skin up there in the flower, but that was all. And I think this, this was crucial. Communication, for me, it was the most important part. Communication with Frank Gehry, with SOM, among all of us, there was a lot of information. I would like to fill one of the galleries with the paper we used to do that. Only for exterior cladding, the contractor used 100,000 drawings to make the exterior cladding. So it was huge. And then thousands and thousands of faxes, telephone calls, and to make things easier. But it worked well in the end. Yes, we used topographical stations to fix the location of all the points, not only in the main structure, but then all the secondary structure, also interior, drywall. Everything was done, by hand, but with a lot of accuracy. You mean the titanium? It was not chosen thinking about the thermal properties or reflections. Or in the end, it was more an aesthetical issue because all the waterproofing is solved underneath, and even the thermal insulation. We didn't think too much about thermal properties in terms of reflections of the titanium. It's not also extreme climate. It's very close to the sea, so it's it's rainy but it's mild. Yeah, we don't have strong winters. I remember talking about these titanium reflections and how it works with light. I remember we had a problem once with the waterproofing membrane that was in one of the roofs, because we one day walking there and going through the site, we discovered a burned membrane, and we thought, what's this? Maybe a worker that left somebody a tool, some heat there, and the membrane was burned. Well, let's do it again. They did it again, and the day after it was again the same. And what was the problem? It was the reflection of the sun, due to the shape of the metal facade was concentrating on the rays on that point, burning the waterproofing. So that's a problem. Mm-hmm. Yeah, like a lens. Yeah. Well, we did it thinking that it had to be a long life building. Of course, it's not a cathedral, but our goal was, let's say, 100 years at least. And this was interesting because, Frank Gehry's people and American architects in general are used to a shorter life. And we had to convince them that this was a building in Spain, and it was a building that it had to last longer. I don't have the answer, who knows, but it's, as you have seen, it's quite a risky solution sometimes, but also we did a lot of tests to check it. And I don't know, for instance, titanium, we had a warranty from the supplier of 100 years. So. Of course, and again with the previous question, you have to think that the things inside are extremely expensive. I mean, there we have pictures and pieces of art, very important. So, of course, water leaking, for instance, was a very important thing for us. And this is why we spend a lot of time checking that and making tests, and to be sure that there wouldn't be a water leak on top of a Kandinsky, if that. Yes, I mean, yeah. Yes, I think this was very difficult, but it was one of our 3 goals, to finish within the budget. But, all of them were very important for us. Of course, this was very important from the very beginning. And as I was saying before, Frank Gehry was involved in the process, and it was very hard for us because we had to do a lot of work before construction, and then during construction fight very hard with contractors because, as you were saying, every day there were new things. So we had a contingency in the budget at the beginning that we, little by little, was consumed. But we arrived in the end with money enough to finish within the budget. And we did it also on time. It was open in the summer of '97. Everything was a rush finally, but it was done and it was open. So, well, this was a lot of work, and of course it's a very important thing for every building. I think it was important also the collaboration of crucial piece in any single project, that is the client. He had very clear ideas about how much he wanted to spend and what time and what was the responsibility of any of the pieces involved in the process. And I think this is very important.
Which was the relationship with the local regulation? Did you create any special rules?
No, we complied with all the rules, with all the existing rules. This was, again, part of our work, to check and to inform Gary of all the rules, and then check that all of them were, that we were complying with all of them, including, fire code, handicapped access, also structural, calcs, mechanical, everything was done according to the codes.
As you said, the building may well have been on budget. Working in the industry, it's always intriguing to see contractors asking for money and saying that cost me X amount, I have to replace 50% of the glass panels. Did they all do it to put Bilbao on their CV, or did they not go past them and take any contractor they had financial problems towards the end? Or did they not admit? I can't imagine anyone making profit on that building.
Yeah, that's, some of them did, the one with the cranes and that. But, yeah, that's true. But, nobody went into this adventure thinking about winning a lot of money, all of them knew that there was something more important behind, that they could say, okay, we have done it. And it was very risky for some of them, and at least one of them was in serious problems after the museum. Others, they invested a lot in technology, in human resources, in software, and now they can do things that they didn't do before, and they have this very important reference, and they can go, saying that we have done it, including our company, for instance. We were much smaller before the museum, and after that, it helped a lot to grow. And it's nice how one of the goals of the Basque government that was that, all this museum had to help the local industry to go ahead. It has succeeded in most of the times to do it.
You mentioned before the Bilbao effect on the world about the legacy of Gary's legacy among Spain, the young architects. And then a personal question, if I may, do you think you're able to sell what you learn? Would you advise any student to apply at Gary? So you think because you said it's one of the most of this museum, one of they would be stuck to work for Gary forever. You've never seen a brick for 6 years. So I understand the norm of the artist nowadays should be the artist of Berkeley. But I would say Muneo is probably easier to follow what the young architects in Spain think about this.
Well, I think Gary's, the opinion of the architects about Gary has changed a lot after Bilbao. I don't know what's your opinion. At least in Spain, that's our impression. That was my impression even. I was saying before about this, frivolous architecture of these binoculars and these kind of things. And then when you go there to California, you begin to understand more. And of course, my point of view right now is totally different. But after working with him for 5 years, and again we are working with him, we are still working with him, it's an architecture that I think it doesn't stick to you. You know what I mean? That that you don't feel like making this kind of architecture after it. I don't know if maybe because we have seen how difficult it is. I think also you understand how difficult it is in terms of design, in terms of architectural design. And you understand that it's not a matter of, playing with some volumes and making some crazy shapes. It's very, very difficult to get to a good result. And you have to spend thousands of hours in the design. And you have to be very, very, you have to have a special, I think you have to be a genius, no? Like I think Frank Gehry is. It's not an easy thing. And I think you can learn a lot about Gehry from very different points of view. Maybe first is the process. You see them how they work, how professional they are. You could think that they are, crazy people. They are very, very professional, and you can learn a lot about how they work. Then this way of approaching problems and situations, this never stopping in front of a difficult thing. There is nothing difficult. I think they work from a point of view that somehow right now, if you have money, you can do, I wouldn't say almost everything, but that's more or less the idea. They are very free from a technical point of view in the first steps, although they never forget about technology and construction. They know they have to build it, so they spend a lot of resources also thinking about how to do it. I don't know. Of course, I would say to any of you to go to Frank Gehry's office to learn there. It's a fantastic world. I don't know. It's a magic place. But I don't think it's a kind of architecture that you can think about it for, you know, a small building anywhere with a low budget. I think it's a good architecture to make these kind of things, and it has proved to work very well.
You said early on in your lecture that due to the time spent between the US and Spain, they wouldn't have time to speak to them, the guys in Nigeria for you.
No, the problem is that, for instance, now it's 8. Now it's 11 o'clock in the morning for them, you know, so we are going to bed and they are beginning to work. That's the, you know, that's why it's a never-ending working team, you know.
No, my question was rather, did they ever get to sleep or not?
Or if we had time to sleep or...
Work, yeah.
Well, yeah, we had, you know, well, sometimes it was hard and, well, you know, we spent a lot of time there, you know, all the weekends and working on Saturdays and Sundays, checking drawings, for instance. That was a very important thing because the contractor had to make shop drawings of everything. We had to review them from a technical point of view, and then we had to send them to Santa Monica so they can check them from an aesthetical point of view, then back 2 hours, then back to the contractor. This in a very fast-track process. So of course, yeah, we had to work a lot, but well, we are still here. Maybe with not so much hair, but it's okay.
Right. I didn't realize it was 8 o'clock already. So one more question, and perhaps we'll have to call it a day. Anybody else? Right. There is a microphone there.
If we could say that Gary's architecture is like a signature, landmark, statement architecture, having worked in his design office, was there a mainstay in the way he placed a large column structure canopy that runs the column?
Sorry, what's...
Was he making something kind of that frontal view?
Yeah.
where
Mhm. Yeah. Somehow that's the only elevation of the building. That elevation is composed in a more classical way, let's say with you know, an axis marked up by the column of the canopy, and I remember he was, you know, this balance of pieces, you know, with the tower at the very end, on the left, then other stone pieces on the other side, balancing the composition. So, yeah, somehow, because if you look at the others, there are no elevations, because somehow it's the result of the way they work. The elevations they prepare for drawings are just, you know, a result made in the final day. I mean, they work always with the model, and it's interesting how they put the models on top of a, you know, turning base, and they look, and they look, and they take pictures, and they take pictures. And they use always Polaroid cameras, and they put the date and the hour the picture was taken, no? And they, because in this process they, well, sometimes going back is possible, although always it's this always going ahead. But yes, I think that's that elevation and that portion is the most I don't know, yeah, emblematic could be the word.
And was he showing the metal structure underneath the canopy? Is that one of the
Yes.
pictures
Mhm.
that she shows?
Yeah, although one of the persons involved in that told me that in the end they were not happy about how the structure looked underneath the canopy. So, but it was nice, you know, because during construction they had a lot of feelings. They were used to work in the models. I remember the day I took Edwin to the very top of the flower. I mean, he was so happy, you know, and he was saying, "Oh, 1-to-1, finally," you know. It was Or Frank Gehry, I remember, he was going down the ramp and saying, well, I'm the most happy architect in the world. I think he had reasons to think, if you would think about the enormous effort of thousands of people working to make this building possible. It was a nice dream.
So I think we can carry on privately now, so we call we'll proceed to an end. Anyway, he's going to be around because they have opened, in fact. They are opening an office in London, so obviously, they're going to be around. I don't know who will be around in London, but certainly, I suppose that with Cesar's involvement in the firm, he will have to come here very often. So we might be able to see them again. Well, let's
Okay,
show our
thank
thanks
you.
again.